Let's begin this exploration of the forces with the one which differentiates us and gives us the ability to fly: lift. Before we get into the details, a quick revision of terminology. The chord line, the line which is marked red on the aerofoil diagram here, is a straight line joining the centre of curvature of the leading edge of the wing with the back of the trailing edge of the wing. The camber line, marked in green here, is a line joining the points equidistant between the top and bottom surface of the wing all the way along the chord line. This describes the curvature overall of the wing. And finally, angle of attack. The blue straight line marked here as the relative airflow, the airflow which is approaching the wing. The angle of attack is the angle between the mean chord line and this relative airflow, and is often denoted by the Greek letter alpha. So, how is lift generated? Well, the approaching airflow flows over the top and bottom surfaces of the wing. The wing acts as a venturi, causing a slight drop in pressure as the air is accelerated over the top surface and under the bottom surface of the wing. Versus the ambient pressure, the air pressure below the wing is at a slightly lower pressure, and above the wing is at a lower pressure still. So that creates a pressure differential between the bottom surface of the wing and the top surface of the wing, which sees lower pressure above the wing than below the wing. This pressure differential causes the wing to effectively be sucked up into the air. The lift equation, which you will all remember very well, is that lift is equal to the coefficient of lift multiplied by a half, multiplied by rho, the air density, multiplied by v squared, the speed, multiplied by s, the surface area of the wing. The coefficient of lift is a factor which has several different components, which are a function of the shape of the wing, the angle at which it's approaching the airflow, its curvature, the camber, and many other factors are also wrapped up in this coefficient of lift. Let's not get too bogged down in the maths. What does this mean to us? It means that lift, we can say, is dependent on several factors: the wing shape, the angle of attack, the air density, the speed, and the wing area. As pilots, let's simplify things further. What can we influence at any given moment for the conditions that we find ourselves in? Well, it's simply angle of attack and speed. You can argue that we may be able to change wing shape by deploying flap, or wing area by using our high lift devices. We could change the air density by climbing to a higher altitude or descending to a lower altitude. But let's keep things simple at the moment. For any given moment in time, in any set of conditions, we can instantly change the angle of attack or the speed. Let's have a look in more detail at this angle of attack and the effect that it has on our ability to fly the wing. For any given angle of attack, we'll produce a quantity of lift. If we reduce the angle of attack, the quantity of lift will be reduced. If we increase the speed that we are travelling through the air, we will see an increase in the lift for any given angle of attack. If we slow the aeroplane down, the only way that we can produce the same quantity of lift is by increasing the angle of attack. How do we change the angle of attack of the wing? I mean, the wings are, in most aeroplanes, not going to move on the aircraft. As the wings are bolted to the aeroplane, the way that we will change the angle of attack is through pitching the nose of the aeroplane up or down. So what we can say is that in forward flight, when we move the elevator, is the angle of attack that we're changing. Now, as we said, for a given airspeed, if we increase the angle of attack, the alpha, we will see an increase in the coefficient of lift. And this relationship will see the coefficient of lift increase in direct proportion with the alpha, the angle of attack. Now, there's a little nuance to this, which I'm sure you're already aware of. and we'll talk about it in a little bit more detail. What we can say is that the angle of attack, the alpha, as it is increased, we will increase the lift until we reach the point at which the wing stalls, which we will examine in a bit more detail in a short while. At that critical angle of attack, the amount of lift that the wing is generating drops off dramatically. So we can say that the lift produced by a wing will increase in proportion to the angle of attack until we reach the critical angle of attack, or the stalling angle of attack, and at that point the lift will now start to rapidly decrease and the drag will increase. In the next video we'll move on to drag.